Welcome to homework.
This question, we are asked which of the following collections are a partition of a real number. So I will assume that you understand what real number is by this point. And when I use variable x, I would mean real numbers. I don't want to say it every time, so here goes. And the first one is very simple, right? It's negative real number, 0, and positive real numbers. So the three sets union together, they made up the whole real number, obviously. And any two of them don't intersect, so don't have anything in common. If you intersect any of them, is gonna give empty sets. So it clear two conditions for being a partition. So this is partition. I hope this is clear to everyone. Next, the rational and irrational. So this requires a bit of background knowledge. So real number is made up of rational and irrational numbers. Okay, in this question, I will just use this as irrational number, and it's kind of retroactive. But this is sometimes we refer to irrational as this because it is what it really is. So it's real number that's not rational. That's how we one way to define it. And so it should be obvious that the two combine, the two union will be real numbers. And what about the intersection? They do not intersect. So the intersection will be empty. By the definition, you can see that these two intersect will be empty, right? Irrational numbers are those that is real but not rational, and rational number is those that can be written as fraction of integers. So a and b has to be integers with b not zeros. So there exists real number that's not cannot be written in this form. The famous one is e, the natural number e, and the pi. You have to come across pi at some point in your life if you go to high school. So these two are the most famous examples. Okay. Next. So it is a partition. Next, intervals of the form k to k plus 1, but it close. Pay attention to the border. It close on both sides. So this is clearly not a partition. Why? Because we have 1, 2 intersect with 2, 3, and it give 2, right? Because 2 is exactly at the border and they both share the number 2, which is not empty. So yeah, it's not partition. Next, here is not partition also, but for the different reason. So every interval here do not intersect with each other, but they're missing integer, right? So 1, the number 1 is not in any partition of this form ever, right? So when we union everything together, 1 will not be in the product of the union. So it will not make up the whole real number. All right, I hope this is clear. Now the interval of this form, we open on the left and close on the right. Now we have a partition. Why? Firstly, when you union everything here together by having the right side closed, every any integer will be in one of the interval, right? Because by this definition, and so their union will be R itself, but they also do not intersect. So any two interval, if we choose for argument's sake the consecutive one here, if they're gonna share anything, it's gonna be this border, the k plus 1, right? But this is open, this is closed, so intersection will be empty. The second one don't have this element. Okay, so I hope this clarifies that it is a partition. The next one, this is a fancy way of saying the interval n to n plus 1, where the right side is open, the left side is closed. So it's like a mirror image of the previous case, but it has pretty much the same property. So their union will make up the whole R, the whole real number, because integer is accounted for, but any intersection is empty, right? Because the open and close thing like before. So this is partition of real number. Okay, hope they are all clear to you, and that is it for this question. Thank you.